Hi, this is Dr. Dominic White from George Mason University. This is the first video lecture of CDS 101, an introduction to computational and data sciences, and so I would like to extend a warm welcome to the course. As this is an introductory course, I expect that for most of you, this is your first encounter with both computational science and data science. You probably have a lot of questions. What is computational science? What is data science? Isn't science just people in lab coats mixing chemicals and writing on blackboards? What do computers have to do with that? Well, I've got great news for you. In this video, I'm going to answer those questions. Let's start with a very basic question. What is science? You may have a loose notion of science as eccentric gentlemen with crazy hair who come up with complicated theories and unintelligible equations. It would be easy to blame Hollywood and the media for reinforcing this stereotype, but it's been around for a while. We can go all the way back to the ancient Greeks to find a story about an early scientist called Archimedes, who was lying in his bath one day when, in a flash of inspiration, he realized that the volume of water displaced by an object could be used to calculate its size. Seized with enthusiasm, he leapt out of his bath and, so the story goes, ran naked through the streets shouting "Eureka," which translates to "I have found it." Leaving aside the questionable historical accuracy of this tale, I want to make the point that neither Einstein nor Archimedes embody what science is. Science is not about particular individuals. Science is a way of looking at the world, a philosophy of how one should seek to discover the underlying truths of the universe. We call this philosophy, this way of looking, the scientific method. And the scientific method is really very simple. It says that you should come up with a hypothesis about how the world works, but then you must go out and collect evidence that either supports or contradicts your hypothesis. Based on your findings, you might decide that your hypothesis needs changing. But whether you found support for your original hypothesis or contradicted it and had to change it, you have to go back to the start of the list and repeat it all over again. As scientists, we can never say that we have proven our hypothesis, merely that we have not yet found evidence to contradict it. By keeping a skeptical open mind like this, we prevent ourselves from becoming attached to an idea that might turn out to be wrong if we examined it in a different way. Science is a constant process of refining and improving upon existing ideas. Okay, so what is computational science? As illustrated by this diagram, it is the intersection of mathematics, computer science, and science itself. Many problems across all the scientific disciplines are mathematical in nature. However, they require a lot of calculation to solve, far more than a human being can realistically calculate. Fortunately, computers can do math extremely quickly, and so computational science is about how we use computers to solve these scientific problems. I hope this diagram also illustrates the difference between computer science and computational science. Computer science is the study of computers generally. How do you build and operate one for any use? Games, websites, even online lecture videos. Computational science takes parts of computer science and uses them to solve real-world scientific problems. In this course, we will not delve too deeply into computational science. In other words, we are going to learn to program and use computers, but we will not worry about the nitty-gritty of what's happening inside the computer itself. However, CDS 130 does go into these topics in more detail, and if you enjoy this course, I would highly recommend taking CDS 130 as well. While CDS 130 focuses on computational science, in this class, CDS 101, we will focus more on data science. What is data science? Well, every data scientist you ask that question to would give you a different answer, but to my mind, data science is about generating insights from data. As with computational science, we can see that it lies at the intersection of other disciplines. In this case, we will take methods from statistics, tools from subfields of computer science called machine learning and databases, and then apply those methods and tools to particular scientific problems. However, you should note that the computational and data sciences are two sides of the same coin. Remember that in science we oscillate between the theory, the hypothesis, and the experiment to test that hypothesis. Computational science allows us to use computers to do an experiment to test our hypothesis. But that experiment will generate data, and we can use data science to analyze that data and draw insights from it, which then inform our original hypothesis. So why should you care about this course? Well, computers are now incredibly important in every area of science. I don't know a single scientist who doesn't spend a large amount of time analyzing data on a computer, and most of them also have to write their own computer programs. Unfortunately, as illustrated by the data from this study, most science students don't have to learn how to program as part of their degrees. This was certainly the case when I was a student. We didn't have a single computer course, and even in graduate school, computer skills are treated as an extracurricular activity that you have to pick up on your own. So if you have any interest in a particular field of science, this class and others in the CDS program will be a great complement to your studies. Okay, Dr. White, I hear some of you saying, but I don't care about science. I'm just here because this is a general education class that I have to take. Well, I'd argue that you should still care about this course. We're living in a world where increasingly everything is either a computer or is attached to one, and all those computers are producing data. Knowing how to work with computers and data, even if it's not your primary job responsibility, will make you more employable and more successful. Here are a few examples of the ways that data is being used in this day and age. The picture in the top left is from the Large Hadron Collider in Switzerland. This is a huge donut-shaped tunnel, 17 miles long, that speeds tiny subatomic particles up to very high speeds and then bashes them into each other and looks at what comes out of the wreckage. The sensors in this 17-mile-long donut generate about a petabyte of data per second. A petabyte. That's 1,000,000 gigabytes of data per second. That's too much to even store in its raw form. So as you can imagine, there's a lot of computational science going on to process that data, and then a lot of data science to analyze it afterwards. Below that is a picture of some pills. What do they have to do with data? Well, the healthcare industry is increasingly trying to use data to find new medicines, cure illnesses, and treat patients more effectively. It's likely that within our lifetimes, you'll go to a computer when you get sick rather than a human doctor, and the computer will use records of similar symptoms to yours to diagnose your illness. You can even find very basic websites that will do this for you today, although I would still recommend going to a real doctor for now. And finally, there's Shakespeare. Yes, even you English majors are not safe from data. For many years, there's been some debate over who actually wrote several of the Bard's plays. Recently, data scientists have started to use computers to analyze the text and determine who wrote each one. Although we'll probably never be completely sure, it does look like some of the plays may have been written by others, or at least have had contributions from collaborators. So I hope I've convinced you that this class is worth your time, and I look forward to telling you more in the next video.